So the question here says a particle P is projected with a speed u meters per second at an angle theta above the horizontal from a point O and moves freely under gravity. After P seconds, the speed of P is 3/4 u. So on part A, show that 7/16 of u squared minus 100 u of sine theta plus 2,500 is equal to 0. Okay, so that's the question. Okay, that's the question. All right, so here we can make a small illustration of what's going on. So we have a horizontal ground and a particle P being projected from a point O, and it's with a speed of u meters per second, and it is being projected, okay, at an angle theta above the horizontal, and it moves freely after gravity. And they also say after 5 seconds, the speed of P, okay, that's a very important part. After 5 seconds, the speed of P is 3/4 of u. Now, the speed of a particle at any instant can be found by V is equal to the square root of Vx squared plus Vy squared. Do you still recall that?
Yes.
Okay, so that's how we find the speed of a particle at any instant. All right. Now, when it comes to the horizontal component of speed, the horizontal component of speed is the same throughout the motion. It's the same as the initial one, which was u cos of theta. All right. So it's the very same one. And when it comes to Vy, we can use u sine theta minus gt to find Vy. This is derived from V is equal to u plus at. So this would be u sine theta minus gt. Let's use 10. Yes, 10. So 10 times 5 seconds, right? So it's u sine theta minus 50, basically. All right. So this is what we have. So we have Vx and we have Vy here. Okay, so Vy here. And now we can now say V squared. Okay, I'm just using now this formula for speed is equal to Vx squared, which would be u squared cos squared theta, all right, plus Vy squared, which is u sine theta minus 50 squared. So this would be u squared cos squared theta plus u squared sine squared theta minus 100 u sine theta. 50 squared, that's 2,500. I hope this is all good.
Yes. Yeah.
Okay. But we've also been told what u is, what v is. They said it's the speed of the particle is 3/4 of u. So we have that on the left side. So that's 3/4 of u all squared. All right. So we have on the left side 9/16 u squared being equal to, all right. If you look at this too, we can factor out u squared and have cos squared theta plus sine squared theta, which is 1. So we are left with u squared minus 100 u sine theta plus 2,500. Did you get that?
Yes, I got that.
You got that right. That's fine. So let's move 9/u squared to the right. So
Oh,
u squared, okay, if we say u
wait,
squared, oh, sorry.
I think there's one thing that's forgotten here. Um, you know the thing with like u squared. Oh wait, did you just make it one? Did you factor out cos squared theta and sine squared theta to make one?
Oh yes, that's how I got u squared here.
Okay, never mind. Yeah, it's fine.
Okay. All right. That's fine. Let's move 9 over 16 u squared to the right. It will now be u squared minus 9 over 16 u squared minus 100 u sine theta plus 2500. All right. So 0 would be, what's u squared minus 9 over 16 u squared?
It's 7 over 16.
7 over 16 u squared minus 100 u sine theta plus 2500. All right. I'm sure that's what they want us to show here.
Yes.
All right. So we'll say here shown. All right. What do you think of this question, this first part?
Yes. Yeah, I get it.
Okay, that's fine. Let's move on to part two. Part B. All right. So on part B, the question says, it is given that the velocity of P after 5 seconds is perpendicular to the initial velocity. Find in either order the value of u and the value of sine theta. Okay. So let's work on this question, right? Let's work on it. Here they are saying that the velocity of P after 5 seconds is perpendicular to the initial velocity. Okay. Let's see how that is. Okay. So I'll take the sketch here and I'm going to place it right here. Okay, so we have this thing here and the direction, the velocity after 5 seconds. So it could be that after 5 seconds, okay, maybe the particle was here. All right, just as an example, just for illustration purposes. So let's say it was here after 5 seconds, which means its direction was going this way, say. That's the direction of the velocity, v, all right? But this direction, they're saying that it is perpendicular to the direction of the initial direction or the initial velocity. Okay, the two are perpendicular, so they meet at right angles somewhere, maybe extended or something. So, but the directions or the velocities are perpendicular to each other, right? So, what do we know on when it comes to perpendicular directions? Okay, you need to understand that for perpendicular directions, the product of the tangents of their directions, uh, or the angles they make with the horizontal should be equal to -1. Basically, tan theta times tan alpha should be equal to -1, where theta is the direction of the particle at some particular point, and alpha is its direction at another point, which are such that the directions are perpendicular to each other. Okay, so that is something very important for you to know. Okay, so in this case, theta is the angle of projection. Okay, that's the angle of projection. So when we talk of tan theta, basically that's initial velocity in vertical wise over initial velocity horizontal wise. So basically we are saying that tan theta is equal to u sine theta over u cos theta. Okay. And for alpha, alpha is the direction of the particle 5 seconds after projection. So we call that alpha. Okay, 5 seconds after projection. So 5 seconds after projection. Okay, let's have that. 5 seconds after projection, the speed of the particle, let's start with the horizontal component. Yes, Vx will still be u cos theta because the horizontal component of speed does not change throughout the motion because there's no acceleration horizontal wise. Okay, so it's still u cos theta. Vy will be equal to u sine theta minus gt, which is minus 50. Okay, we're just using this, right? Vy, this thing here, we had gotten that earlier. All right. So basically, tan alpha is equal to u sine theta minus 50, and that's over u cos theta. So when we then say tan theta times tan alpha is equal to minus 1, we'll be saying u sine theta over u cos theta, right? Times this is equal to minus 1. We can also interpret it to say it's equal to, oh, okay, let's just do it so that it doesn't confuse. Or we can say it's equal to minus u cos theta over u sine theta minus 50. Okay, it's the same thing. I've just gone a step ahead to move tan alpha to the right by dividing both sides by tan alpha. So it becomes minus 1 over, it's a reciprocal. I hope this part is fine.
Yes, it's fine.
Okay, good. So technically we have cross multiplying u sine theta of u sine theta minus 50 is equal to minus u cos theta of u cos theta. So we have u squared sine squared theta minus 50u sine theta is equal to minus u squared cos squared theta. All right, rearranging, it's u squared sine squared theta plus u squared cos squared theta is equal to 50 u sine theta. On the left side, we get u squared. Do you understand why?
Yeah, because when you factor out sine squared theta plus cos squared theta, you get 1.
Yes. So we have u squared minus 50 u sine theta is equal to 0. So u of u minus 50 sine theta is equal to 0. So u is either equal to 0 or u is equal to 50 sine
Oh.
theta. Okay, you want to ask something?
Hmm?
Oh, sorry. I thought you had said something.
Oh, no, no, I didn't.
You didn't. Okay, no, it's okay. All right. What do they want? They say we should find the value of u and the value of sine theta, right? Okay. So in this particular case, we have gotten that u is equal to 50 sine theta. Okay. So let's take back the equation we had proved or shown right above. Okay, this one. All right, and we're going to say from A, we had gotten that. We had gotten this, right? Which therefore would mean we'll be having 0 being equal to 7 over 16 of 50 sine theta squared minus 100 sine theta of 50 sine theta, right, plus 2,500. Okay.
I've expanded all of them. Do you want me to just say them?
Okay, yes.
For the first one, it's 4,375 over 4 sine squared theta
Mm-hmm.
minus 5,000 sine squared theta,
Mm-hmm.
then plus 2,500.
Okay. What's 5,000 minus 4,375 over 4?
Here it's negative 15,625
Over 4, right?
over 4.
Is equal to 2,500. So sine squared theta should be equal to 2,500, right, times 4 over 1,562.5. What does that give us?
16 over 25.
Really?
Yeah.
Okay. Interesting. Do we still have space? We don't have space. Let me just move this up a little. Okay. Okay, so we're getting 2,500. Okay, the zeros should be here. Oh, so we're getting there. So basically, it means that sine theta should be 4 over 5, right?
Yeah.
Okay, so sine theta is 4 over 5. So what is u? Okay, we remember we got here u to be 50 sine theta. So u would be 50 sine theta, which is 50 or 4 over 5, right?
Yeah.
And what is that? 40?
Wait, are we doing 50 sine 4 over 5 or just 54 over 5?
Yes,
Yeah,
50.
54 over 5, right?
Yes, yes.
40.
U is 40. So this is what we get. Sine theta is 4/5. U is 40. Okay, I hope you understood what we did here.
Yes, I understood. This is so much more, like maybe it's because I take physics, but this is so much better than pure to me.
Sorry, it's better than?
Like it's better than the pure papers in my opinion. Like it's more interesting, I think.
Oh, I see. Yes, it actually is. Actually is.